Hello everyone, today we'll be going through paper 2 of this Henry Park Primary School math examination in preparation for PSLE. So let's do this. The time for paper 2 is about 1 hour and 30 minutes from this examination paper. So ideally you should be spending about 1 hour 15 minutes doing the questions and the other 15 minutes checking your answers. So let's move on to the actual paper. So question 1 says, Jane has some money. She spent $15 and gave Lisa $10, and in the end, both Jane and Lisa had the same amount of money. What we really want to do here, when we know that this is the final situation where we know that they have the same amount of money at the end, so we want to draw a model to visualize it easier, and we actually start from the end because it's so straightforward. It tells us that there's the same amount of money. So it may look something like this, but this is the end, right? So this is after some exchanges have been done. And what are these exchanges? Is Jane actually spent $15. So this looks like here, this chunk is $15, and she also gave Lisa $10. Say this chunk is $10, and originally it was Jane's. So how much more money does Jane have than Lisa at first? How much money does Lisa have at first? We must answer this question like first, right? So it's quite obvious from the model. You see that this $10 is Jane's. So Lisa's actual money is just this portion. So how much more money does Jane have if we draw this line? Right? So this is the same amount of money before this line. But after this line, we see that Jane has $10 plus $15 plus another $10 more than Lisa. So the working is relatively simple. It's just 10 plus 15 plus 10, and you'll get $35, right? $35. Alright, let's move on to the next question 2. Mr. Aziz had some apples. He sold 1/5 the apples on Monday and 80 on Tuesday, and then he was left with 30% he had at first. What we want to do is that we want to convert either this percentage to a fraction or this fraction to a percentage to make it easier, right? Let's convert to this fraction into a percentage first. What is 1/5? 20%, right? Right. So now let's essentially just draw a model, and we see what is the whole situation like. So he sold 20% on Monday and 80 apples on Tuesday, and in the end he was left with 30% of the apples he had at first. How many did he have in the end? So this is in the end, right? This is what we want to find. So right here we have several percentages, and we have a number. So what percentage does this number constitute of its total number of apples? Well, that's also quite simple to decipher. This whole thing is 100%. So we see that 80 apples is equivalent to 100% minus 30% minus 20%, which is 50%. So we want to find the 30% value. So we just take 30 over 50 times 80 apples. And what we get, if we plug it into the calculator, we'll get 48 apples, which is our answer here, right? 48. Question 3 asks, printer A can print 300 pages in 12 minutes, while printer B can print the same number of pages in 10 minutes. If both printers are used at the same time, how many pages can they print in half an hour? It's generally easier to separate it into two for easier calculation. So let's look at printer A first. 300 pages in 12 minutes. Half an hour is 30 minutes. So how many pages will it print in 30 minutes? That's just 30 over 12 times 300 pages, which is 750 pages in half an hour. How about printer B? We see the printer B can print 300 pages in 10 minutes. So in 30 minutes, it's just 30 over 10 times 300. You don't even need to use a calculator because that's just 3 times 300, which is 900 pages. So the total amount of pages is just 750 plus 900, which is 1650 pages. That's your final answer. Next is an angles question where we want to find the particular angle PQR, which is this angle, and a rectangular piece of paper is folded. So when you encounter this sort of folded paper questions, you want to draw how this paper was like or at its original state. So this will look something like this. Yeah, it will be something like this, right? Because so it folds here and this folds there. But what this question really is trying to say to us, right, is that we want to find PQR, and we can merely use angle laws. We see that PQR is on a straight line. We have these angles. So if we take 180 degrees minus these 4 angles, we can actually get PQR. And we also have to notice that this angle, let's call it X, because it is folded over, we realize that this angle X is exactly the same as this angle X. So together it's just 2x degrees. Similarly for this angle Y, together it's just 2y degrees. So what is X? We see that this is a triangle. To find X, we can just take, so X degrees is just use angles in a triangle. Minus 90 degrees minus 71 degrees, we'll get 19 degrees, right? Due to angles in a triangle. And what is Y degrees? We see that it's just the exact same formula as X, but it's 55 degrees here. So we just take 180 minus 90 minus 55. We'll get 35 degrees due to the same angle property. Now we can find PQR. It's just 180 degrees minus 2 times x degrees minus 2 times y degrees, which is 180 degrees minus 2 times 19 degrees minus 2 times 35 degrees. If we put in the calculator, we will get 72 degrees due to angles in a straight line. On a straight line, actually, so it's 72 degrees. Question 5 states that the figure below is made out of square ABCD and rectangle DEFG. Given that BC is 22 and G is the midpoint of AB, find the area of the figure. When we see square, we immediately think all sides are the same. Quickly write down the lengths of all sides, right, to make calculation easier. And G is the midpoint of AB. What does this mean? Right, it means that both these lines are of the same length, AG and BG. So if we take 22 divided by 2, mental calculation is just 11. We want to find the area of the figure, which is the okay, before we find the area of the figure, we have to realize something, is that when we look at, let's call triangle GFA area A, we'll call triangle GAD area B, we'll call triangle ADE area C. What do we realize is that by inspection, we see that area A plus area C is area B. And how can we prove this? Because ultimately you still need some sort of proof when you write it down your workings. We see that if we draw a straight line here, right, this area is equivalent to this area, and this area is equivalent to this area, because AD bisects this rectangle and line AG bisects this rectangle. So the area of the figure is the area of the square plus area A plus area C, which is the area of the square plus area B, as we have already established this relationship. And from then on, it's easy peasy, we can find it out, because area B is just a triangle of 22 and 11. So we just use the triangle formula, half times base times height. We find out the total area of the figure, which comes out to be 605 cm squared. Here we go. Right. So question 6 to 17. Right. For these longer questions, you should write your final answer statement at the end. I'm quite sure you're required to do this for PSLE, and your teachers also encourage you. But for to make this video a bit quicker, I will not write it down. But to just give an example of how you should do it, your final answer statement for this question, when they ask how much money did Chin Meng earn, you should write something like Chin Meng earned. Your answer can be anything each month. Just at the end of your working, so you should write something like that, or there's a possibility that your teachers will minus your marks, right? So let's do this question. He earned the same amount of money each month. In October, he spent 1070 and saved the rest, and he also earned the same amount of money in November. We immediately, when we see same amount of money, when we see October, we see November, we immediately think that we should draw a model. So let's do it. So he earned the same amount of money, which is, so we're making these model bars generally equal in length. In October, he spent 1070, $1,070 and saved the rest. The amount he spent in November was a 30% decrease from what he spent in October. How much did he spend in November actually? Let's just calculate it. Right. So October was 100%. What is a 30% decrease? That's just 100 minus 30, so 70%. That is just 70 over 100 times 1070, which is, it comes out to be $749, right? So he also spent $749. As a result, his savings for November increased by 60%, right? So there's a 60% increase here, and this is 100%, right? The original amount that he saved in October is 100%, so the amount he saved in November is 160%. So we need to find out what this 60% is, and it's quite obvious by looking at this section of our bar graph. So it's just 1070 minus 749. This is equivalent to 60% of what Chin Meng saved in October, right? And what we want to find out is this amount of 100% plus 1070, because that's what he earns in a month, right? So if we calculate out 1070 minus 749 first, we will see that 60% is equivalent to $321. So, and then we can already calculate the final answer, right? So amount of money per month, that's just 100%, so it's just 100 over 60 times 321 plus 1070. If you want, you can also use this 160%, so that will be 160 over 100 times 321 plus 749. But let's just use this, let's stick with this working for, simplicity's sake. and what we get when we eventually compute it, right, is our final answer is $1605. Yeah, that's your final answer, and remember to write your final answer statement. Question 7 about water charge. Alright, a water charge question. Madam Selima's family used 40 cubic meters of water in August. How much was her family charge for their water usage? 40 cubic meters falls under this range entirely, right? So it's also quite simple, right? So under this range, it's $1.21 per cubic meter. So how much was the family charge? You just take $1.21 times 40, right? Which is $48.40, right? Question B, slightly more complicated. Mr. Mutu spent $103.12 on water usage in September. What was the volume of water? So let's say this is the volume of water that he used, right? So the first 40 cubic meters goes under this charge of $1.21 per cubic meter. So this is already 48.40. So we need to find out the remaining, right? Remaining costs after 40 cubic meters, right? Which is just 103.12 minus 48.40. And we'll get 54.72. So this part is 54.72. But the mystery is how many cubic meters is this, which we can also find out because they do give us a value of $1.52 per cubic meter. So cubic meter after 40 cubic meters, amount of, yeah, so we have to find out this value, which is just 54.72 over 1.52. We'll get 36. So total volume of water is just 40 cubic meters plus 36 cubic meters, which is 76 cubic meters. Done. Question 8 about angles again. Sorry, not angles, but just the figure, right, and its area, its perimeter. We have to find the perimeter of this figure in terms of P in the simplest form. Let's see. So it is made out of rhombus, BCDF. What is a characteristic of a rhombus is that all its sides have equal length. And two identical right angle isosceles triangles, ABF and EFD. Right angle isosceles triangles, you must remember that they also have two sides of the equal length, and you can tell it is AF, FB, FE, FD, these sides by inspection alone, because clearly AB and ED is the longer side, so you can eliminate that. The perimeter of the rhombus BCDF is 12p. So what is the length of one side? That's just 12p over 4. 3p, so we know this is 3p, and the length of AB is p plus 3. So this would be 3p, this would be p plus 3, this would be 3p and 3p. What is the perimeter of the figure? Also quite simple, you just take everything and you add that up, right? P plus 3 plus 3p plus 3p plus p plus 3 plus 3p plus 3p, right? And you take everything, you add it up, you take the p's, right? 1, 4, 7, 8 plus 6, that'll be 14p plus 6. Right, that's your perimeter. Right, 14p plus 6. And find the area of triangle ABF given that p equals 6. How we find this particular area? We have to find its base and height. So let's let FB be the base. right? Because we immediately see that this is a right angle, which means that we can easily figure out its height. So this would be A, F, and B. Right, so this is 3p. AF is 3p, and FB is also 3p. Right, so the area of ABF is half times base times height. But what is 3p? P equals 6, so 3p is naturally 18. 6 times 3 equals 18. So just half times 18 times 18, which is 162 cm squared. Let's look at question 9. What is the average number of burgers sold in each month from February to May? Just for average questions, you just take the total number and divide by the number of months, right? So this could be, so between 300 and 200, we know this is 250. What is in between 200 and 250? That's 225. So we know each division is an increment of 25. Right, so this is 250, this is 325, this is one increment lower, so it's 225, and this is 400. We can read it directly from the graph. So what is the average number of burgers? That is just 250 plus 325 plus 225 plus 400. Take the whole thing divided by 4. Let's see what we get. We get 300. That's the average number of burgers, right? 300 burgers. Find the percentage increase in the number of burgers sold from February to March. So this is the question B. Right, so we will assume that February is 100%. Right, so 100% will be 250 burgers. So 325 would naturally be 325 over 250 times 100%. Which is actually 130%. So the percentage increase is just 130% minus the original percentage, which is 100%. You'll get 30%. That's your answer for part B. Alright, so let's move on to question 10. At Candyland, chocolates are only sold in packets of 5, and lollipops are only sold in packets of 4, as shown below. And Judy spent this amount on chocolates and lollipops. She put all of them into bags. Let this be a bag such that there were 3 chocolates and 2 sticks of lollipops in each bag. And how much did she spend in total? She spent $101.34 in total. Naturally, we want to find out what is the cost of each bag first to find out exactly how many bags there are. Each bag has 3 chocolate and 2 lollipops. So we can work it out from there. Right, so the cost of one bag is equivalent to, because it's 3 chocolates, so that'll be 3 out of 5, because right here is 5 chocolates for $1.99, so that'll be 3 out of 5 times $1.99 plus 2 out of 4 times 0 times 99 cents, right? And let's see what we will actually get if we plug it into the calculator. We will get a value of $1.68.9. It looks like a scary number. Your teachers will definitely tell you to round it up to $1.69. But in the case of this question, we actually don't need to, because this is the exact cost of each bag. So now we can find the number of bags relatively easily, which is just take the total amount of money and divide it by the cost of one bag, and we will get 60. So we know that she bought 60 bags, and each bag has 2 lollipops, so the number of lollipops is just 60 times 2. 120, write your FAS. Right, here we go. Let's look at the next question in an art club. The number of girls is 4 times the number of boys. The number of girls who wear specs is 2/5 the total number of children who wear specs. Alright, so let's try to visualize this. So in this art club, there are girls and boys, and among the girls there is specs, non-specs, and this is the same among the boys. So let's assign values to them, right, to make it easier. Right, so let's say this is X. Sorry, let's say this is A, and let's say this is B, let's say this is C, let's say this is D. So the number of girls, which is A plus B, is 4 times the number of boys. Number of girls who wear spectacles, A, is 2/5 the total number of children who wear spectacles in the art club. So that will be the girls who wear spectacles plus the boys who wear spectacles. Given that 170 girls and 20 boys do not wear spectacles, find the total number of girls in the art club. We can replace these numbers with we can replace these constants with actual numbers, right? So this would be 170 and this would be 20. So what we get from this, we have A plus 170 equals 4 times C plus 20. And what we get from this is A equals 2/5 A plus C, right? Which is still the same, right? So how can we further simplify this? Well, this you just expand the 2/5, so there will be 2/5 times A plus 2/5 of C. You'll get just take away 2/5A, and we'll actually get 3/5 A equals 2/5 C. If we multiply by 5, we just get 3A equals 2C. Right, so let's take this equation. So we'll write it down here, and we'll also expand this, right? So it'll be 4C plus AT. But since 3A is 2C, we know that 4C is 6A. So here we've isolated this value, this particular value A, and it's relatively simple from here, right? So it's just A plus 90 equals 6A, 90 equals 5A, A equals 18, right? And you want to find the number of girls in the art club. So that is just 18 plus 170, which is 188. Write your final answer statement, and there's your answer. Let's look at the next question. Mr. Suraj paid $4,705 for admission tickets for a group of tourists. 2/3 of the tourists were children, the remaining were adults and senior citizens in a ratio of 5:2. How many children were there? So we're given a ratio here, so to simplify it, we just make the whole thing a ratio. So we have children to adults to senior citizens, right? Let's just call it elderly because it's simpler. So we know that 2/3 of the tourists were children, so this would be 2 units, and this would be 1 unit, right? Because the total number of units is 3, and since there's 2 units of children, the amount of children is actually 2/3 when you compare it to the tourists, right? And if you draw another ratio, you know that the adults and senior citizens, the ratio is 5:2. So we see that this 1 unit makes up this 5 and 2. So let's call this parts. 5 parts and 2 parts. So we know that 1 unit is proportional to 7 parts. So then what is 2 units? Right? 2 units is naturally proportional to 14 parts. 7 times 2. Right, so the ratio is just 14 to 5 to 2. Right, so let's call 14 children, 5 adults, and 2 elderly. Let's call this one batch. One batch of tourists, right? It'll make our calculations much simpler. Right? So cost of one batch, because we want to find we know the total cost. If we find out the total cost of one batch, we can divide the total cost by the cost of one batch to get the number of batches, right? So that will just be 14 times 43 plus 5 times 55 plus 2 times 32. And that is $941. So the number of batches is his total amount of spending, 4705, divided by 941, which is 5. So we can find out the number of children. So that's just 5 times. How many children are there in a batch? We have 14. 5 times 14, we plug it in, get 70. Write your FAS, and this is your answer. Let's look at question 13. At first, a rectangular tank measuring 1.5 meters by 1.2 by 60 cm was half filled with water. A tap was then turned on for half an hour to allow water. In the end, the tank was 3/5 filled. How many liters flow from the tap per minute? You must know that 1 liter is equivalent to 1000 cm cube, right, or cubic centimeter. So let's just convert these values into centimeters. So this would be 150 cm, this would be 120 cm. Right, so let's assume this is just half filled first. So at the end, we know that at the end, the volume of water increased to 3/5. Right, so what is the difference, right? What is the difference? So the difference is just 3/5 minus half, right, which is 1/10 of the tank. So when the tap was turned on for half an hour, 1 out of 10 of the tank got filled, right? So what is this value in particular? So we just calculate it, right? 1 out of 10 times the volume of the tank, which is 150 times 120 times 60. That is how much water got filled by this tap. So that is 108000 cm cube, or 108 liters. Right, so this is the amount of water filled by the tap in 30 minutes. Right, as you can see, the tap was turned on for half an hour. Half an hour is just 30 minutes. So you want to find how many liters of water flowed from the tap per minute, right? So amount flowed per minute. You just divide 108 liters by 30. You'll get 3.6 liters. That is your final answer. Let's look at question 14. Alright, an area and perimeter question. Usually, these questions are really they are quite complicated. You have to do lots of equations. So the trick for this is that you don't do everything into one chunk. For example, the area is blah blah plus blah blah plus blah blah. It's really easy to mess up, to get something wrong. You want to try to do your best to split up your workings, right? To make it simpler for you, so you'll make less careless mistakes. So let's look at the question. The outline is formed by a semicircle, 4 identical quarter circles, and 2 straight lines. So this is 80. Naturally, we know that this is 40. By extension, this is also 20. You can just look at that by inspection. There's not even a need for proof. Now you want to find the area of the shaded figure. What is the area of the shaded figure? Right. If you look carefully, the area of the shaded figure is this big semicircle, right, this whole thing, minus two of these small quarter circles, this, and minus this thing, right, this rectangle. But still you have to add these two quarter circles, right, as you see here. But you realize that these two quarter circles is the same area as these two quarter circles, so these cancel out. So the area of the shaded is just this big semicircle here, right? It's just the big semicircle you see minus this rectangle, right, which is here. So the area of shaded, we just use the formula, so pi r squared, right, for the area of a circle. So the area of a semicircle will be half pi, which is 3.14. Don't write pi, right, 3.14. What is the radius? Right, so the diameter is 18, radius is 40 squared, right? And minus the area of this this rectangle. So we know this is 80, we know this is 40, this length is 20. Naturally this length is 20 also because it's a quarter circle, right? And this length is 40, so it's just minus 20 times 40. You'll get half times 3.14 times 40 squared minus 20 times 40. We'll get 1712 cm squared. Right. Next, we need to find the perimeter of the shaded figure. Right, let me just erase this so it'll be clearer for us to see exactly what we want. So the perimeter of the shaded figure is this plus this plus this plus this plus this plus this plus this, right? It looks like we have to do quite a lot, but we realize that the perimeter is just the perimeter of the large semicircle here plus, when we carefully examine this perimeter, right, and look at this arrow, this perimeter, realize that this is identical to this perimeter, and this perimeter, because they're all the perimeters of the quarter circle. So it's just 4 times this plus what's left is just this straight line, which is, and we have two of them, and we've also established that the length of the straight line is 20, so it's just plus 4 times 20. Right. And now that simplifies our equation so much. So the perimeter of the shaded is just, right, what's the perimeter of a semicircle? The perimeter of a circle is 2 pi r, so naturally the perimeter of the semicircle is just half 2 pi r, which is pi r. Right. So it's just 3.14 times, because this question wants us to take pi equals 3.14, so we just take 3.14 times r. What is the radius of the big semicircle? It's 40 cm plus these 4 small quarter circles. Right, the area, the formula for the perimeter of a quarter circle is just 1/4 times 2 pi r, because this is a circle, and you'll get half pi r, right, times 4 times half times pi times r. What's r? R is just 20 cm from here. We can just write it down. Plus 4 times 20. That's the last part of our formula. So this is the semicircle, the perimeter of the semicircle. Right. This is the 4 quarter circles. And this is the straight line. Right, these are the straight lines. Oh, I'm sorry, not 4 times 20, right, just 2 times 20, because there are just 2 straight lines here. So just 2 times 20. Plug it all in. Let's see what we get. We'll get 291.2 cm, which is actually the answer here. So write your final answer statements, both of them, and let's move on to the next question. In this figure below, find the sum of P, Q, R, S, T, and U. Immediately we'll see that we can use angles in a straight line add up to 180 degrees, this particular angle property here. But we need to know what this angle is. But it's fine, right? It's fine. We can just call these unknown angles, say X, Y, and Z. So we see that P plus X plus U plus T plus C plus S plus Q plus Y plus R is all equivalent to 180 times 3, because that's 3 straight lines, which is equivalent to 180 times 3 is 540 degrees. And we can also use the angles in a triangle property. X, Y, and Z are all angles in a triangle. So we know that X plus Y plus Z equals 180 degrees, right? Angles in a triangle. But hey, we see that X, Y, and Z is also in this formula above, this equation above. Hence, we can just eliminate them and just take so this whole thing consisting of P plus U plus T plus S plus Q plus R is just 540 minus 180, which is 360 degrees. And if you see, all these angles here is actually what the question wants us to find. So bam, you've got your answer of 360 degrees. Let's move on to the next question. The figure below is not drawn to scale, and in this particular figure, AGC is a triangle where BH is parallel to EG, and BD equals BE equals EF. Now when you see all these information, you must write it down. Here they've already given you the notation for the parallel lines, which is good, but they haven't made it really clear about these equal lines, right? These lines that have equal length. So we just need to write it down quickly to make it clearer for us. So BD is equivalent to BE is equivalent to EF, right? That's good. We see that triangle BED is isosceles, right? Because these two sides BE and BD have the same length, so it's isosceles. So what this means is that angle BED is the same as angle BDE. Right, so let's find angle Z. So how will we exactly do this? Well, let's try to make use of certain angle properties, we say. So let's draw your attention to this pair of parallel lines BH and GD. Right, so what this means is essentially X, Y, and Z. We see that if we can extend these lines, right, because they're parallel, and we can find out certain relationships, right, from these angles. So we see that this 40 degrees, right, if we call this point Z, for example, we see that this angle is also 40 degrees, right? So angle ZBC is equivalent to angle ABH, right? Because they're all 40 degrees, right? Because of this particular angle property, right? Vertically opposite angles. And now we can see, now this is actually really hard to visualize, even for me, but look at this alternate angle, right? So we see that this angle of BDE is equivalent to ZBD, which is 40 degrees plus 32, which is 72 degrees due to alternate angles. Right, so and from then on we can find out angle Z lah, which is just 180 degrees minus 72 times 2, which is actually 36 degrees. Our isosceles triangle. Let's move on to question 16. The graphs below show the number of television sets sold by shop A and the amount of money collected by shop B from the sale of television sets from June to September. Given that shop B sold each television set at a fixed price of $1,200, did it sell more, fewer, or an equal number of television sets than shop A in the month of July? So this is what we're looking at, the month of July. How much money is this, right? So we know that so in the middle we know that this is let me just make my font smaller. Right, in the middle we know that this is $150,000. Yeah, and in fact this is just, honestly, this is just trial and error. 1, 2, 3, 4, 5 divisions, 20,000 over 5, it's just 4,000 per division. So this would be 144000, 148000, 152000, 156000. So this, what exactly is this value? We can trace it, right? We find that, oh, it's actually $156,000. Right, so the amount of television sets is 156,000 over 12 over $1,200, and what we get is 130 television sets. Compare this to shop A in the month of July, which only sold this will be 90. So yeah, they only sold 90 television sets, right? So shop A sold 90, while shop B sold 130. Hence, shop B sold more. Right, it's more. Let's see. The next sub question. Shop A had a promotion in August where each television set was sold at 30% discount. Given that shop A collected this amount more than B in August, find the amount of discount given by shop A for each TV sold. Right, we're looking at the month of August, right? How many television sets is this? 200, 180, this is 190, and looks like they sold 190 TV sets, right? So shop A sold 190 TV sets in August. Right, compare this to shop B. How much did shop B make, right? So 140,000, and let's trace the line here. 2 divisions, that'll be 80,000. So 140,000 minus 80,000 is 132,000. So shop B made 132,000. Shop A collected this amount more. So shop A amount of money shop A collected, that's just 132,000 plus 132,000 plus $34,250, and that is 166,250. Alright, so each television set was actually sold at a 30% discount, so that would mean 70% of original price. So let the original price be X. So 70% is 70 out of 100. So 70 out of 100x, right, equals this total cost divided by 190 TV sets. So you'll get 875. And hence we can find X. Oh no, you want to find the discount, right? So the discount is 30 over 100x. So you just take 875 divided by 100 times. Actually, it is better if you find X first, right? So X is 875 times 100 divided by 70. And then you can find 30 out of 100x, which is just 30 out of 100 times 1250, which is 375 degrees, write your FAS. Right, 375 degrees. Right, final question, question 17. The table below shows the number of sticks for the first 4 figures. The pattern question, quite usual in PSLE for the last question, right? So we see that figure 1 has like the first layer, figure 2 is like the second layer with this sort of support. It looks like it's building some sort of tower, right? And yeah, it just continues up and up, right? So figure 1, so you realize for the odd number of figures, right? For the odd number of figures, so because we start from 0 sticks here, and now we move to 3 sticks, and from here we move to 7 sticks, move to 10 sticks, move to 14 sticks. We realize that what the odd number of figures does is it builds one more level, right? So from figure 2 to figure 3, it builds one more level and uses 3 sticks to build that. So from even to odd, 3 sticks, right? But from odd to even, what is from odd to even? It's from 2 to 3, from from 1 to 2, from 3 to 4, for example. We see that they use 4 sticks. So from 4 to 5 is from even to odd. So that's just plus 3. We get 17, right? How many sticks are there in figure 28, right? So we realize that if we group, because this is plus 4 and this is plus 3 and this is plus 4, etc, etc, right? Dot dot dot. It goes on and on. For these sort of alternating patterns, it's really good to group them into like this. For example, this whole chunk is plus 7. This whole chunk is plus 7, right? So we're just for figure 28, right? We see that we can essentially find the pattern by looking at the even figures, right? Because 28 is an even number, like figure 2 is an even number, figure 4 is an even number, right? So figure 2 has figure 2 has 7 sticks. Figure 4 has 14 sticks. Figure 6, 17, so it'll be plus 4, right? So that's 21. Has 21 sticks. So we see that each increment of 2 figures increases by 7, right? Because this is plus 7, plus 7. So figure 28, how many increments would this be? So this is 2 figures, 2 figures. So 28 divided by 2 is 14. So it means there will be 14 times of this. Right, so from 2 to 4, from 4 to 6, but but also realize that this doesn't start from 0. If it started from 0, it'll be 14 times, but it starts from 2. So it's just you actually just need 13 times of increments of 2. So that'll be, so amount of sticks will just be 13 times, 13 is 14 minus 1, right? So it'll be 13 times 7 plus the original 7 here, which is actually 14 times 7, right? Which is 98. Right, so question C states Cedric used 2327 sticks to form a figure. Which figure number did he form? So we see that every 2 figures uses 7 sticks. Right, so he used 2327 sticks. So we can take 2327 divided by 7 first. We'll get 332 with a particular remainder. Right, so we'll get what is this remainder? It is 3. Right, so this 332 is the amount of figure numbers, of divisions of 2 figure numbers, right? So that's 332 times 2. What is this R3? It means that there's 3 remainder. Remember that this is even, right? So because 332 times 2, so this is figure number 664, right? And he has 3 extra sticks. You will recall that when we are going from an even number to an odd number, we take 3 extra sticks. So this is just perfect, plus 1 more figure number. So that'll be just figure number 665. Right, that's our answer. And I really do apologize if my explanation for this question was not very good, because for this type of question is usually quite, and it's a matter of like intuition. It's a matter of so-called like math sense, right? When you've done a lot of these questions, you'll naturally know how to do them. So I also apologize if my explanation for this question was not the best, but honestly, all in all, I really hope it helped you. If you're like a P6 student and you're revising for a PSLE, yeah, I really do hope that this has at least had some sort of benefit to you and into your learning journey. And with that, I'll end this session. Alright, thank you.